All right, today what we're looking at is something that's on the second page of Blue Notes. It's called locating positions is what we're looking at today. So it'd be like mapping and locating positions on a map. All right. Okay, so let's say I have this circle here, and on my circle there's a dot right there. And what I want to do is I want to try to explain to someone where that dot's located. It's kind of hard to do, all right? Because what am I going to say? It's in the bottom left-hand corner. There's no corners on a circle. It's about an inch or so from the edge. Which edge? All right? So it's pretty hard to describe that point because there's really no reference points on the circle. The only thing I can use as a reference is the edge of it. But I don't know what direction. There's really no accurate way to describe the direction of it. All right? So to make it so I can describe a point, there's a few things I can do better than just having an empty circle like that. One thing I could do is on my circle, I could have a grid system that looks kind of like that, all right? That looks kind of like graph paper. And I could use a bunch of numbers and this way and a bunch of numbers that way. And now, if I wanted to describe that position, there's plenty of reference points on my circle. So this would be really easy. I could say there's a point on my circle at B3. So, because there goes A, B, C, D, E, F, so B would be right there. And then 1, 2, 3, 3 would be right there. So B3, that tells me exactly where that point is. All right, so if I have a grid system like this, it'd be very easy to describe points on there. And there's a lot of things that use grid systems similar to this to locate points. Even a number of games. If you ever play the game Battleship, how you try to find someone's battleship is you go B3 and then tell you if you hit or miss the battleship, and then they go C5, and you tell them if your battleship is located at those coordinates and so forth. So the game Battleship's one example. Another example where you might use a grid system to describe the locations of things is if you're playing chess. All right. I'm the chess club advisor. So if you ever want to join chess club, I'm the guy you want to come to. But with chess, how you describe the positions of the pieces is you say like, if I was moving my pawn, I might say pawn to king's 3, and that describes a position on the chessboard. All right. So a grid system is one way you could set up a system to describe points on a surface. It's not the only way. Another way I could set up a bunch of lines on a circle there to describe a point is I could set them up like this. So what I could do is I could rotate a certain amount around, so it goes like A, B, C, D, E, F. So I could say it's F, and then I could count the number of lines out from the center. So 1, 2, 3, 4. So it's F, 1, 2, 3. F3 would describe that point. All right? It's just another way lines can be drawn to describe positions on a surface like that. Now, what we're looking at today is coordinate systems. That's when you use two numbers to describe a position on a surface. So this would be example one coordinate system, and this would be an example of another coordinate system. Now probably what you would normally think that you use a coordinate system for is to find positions on a globe. And normally you'd probably think that a globe, when you've seen a globe before, you think latitude and longitude. Normally you think of latitude and longitude as being something like this. However, if I'm looking at a globe from the side, all right, my latitude lines go like this, my longitude lines go like that. So if you're looking at a globe from the side, then yeah, the latitude and longitude lines look kind of like that. However, if I take a globe and I look at it from the top, now my latitude lines make circles and my longitude lines crisscross. So when you look at a globe from the top, what you're basically seeing is something like that. So the latitude and longitude system is actually kind of a combination of these two things. When you look at it from the side, it's kind of like this. When you look at it from the top or bottom, it's kind of like that. And that's what we're looking at today. It's coordinate systems and latitude and longitude. All right, so first off, latitude, all right? So latitude are the lines that measure how far north and south you are on a map or on a globe. So whenever I give directions, all right, there's one thing, I'll take a step away from this for a second. Let's say I was given directions on how to get to Burned Area. And I said, you take a left, then you go to the light, you take a right, and then you go couple hundred feet. Right? My directions are missing one very important thing. My directions were missing a reference point or a starting point. So whenever I give directions, I have to have a reference point or a starting point. So with latitude, your reference point, what you're measuring how far north or south from, is the equator. Right? So I'm measuring how far north or south of the equator. So latitude lines are the ones that look like this. Notice they run parallel to each other. And easy way to remember which ones are which is that latitude lines are the ones you can climb like a ladder. So I could climb latitude lines like a ladder. And what they're measuring is how far north or south you are, and the reference point we use for latitude is the equator. How far north or south you are from the equator. So you go from 0 to 90 degrees north, or 0 to 90 degrees south. Whenever you describe a latitude, you want to make sure you put the compass direction on there, right? Because if I just said I was at latitude 45 degrees, I wouldn't know if I was 45 south or 45 north. So you always want to make sure you put your compass direction, whether it's 45 north or 45 south on a latitude. The only latitude that does not have a compass direction is if you're exactly at the equator, then you could just write 0. But otherwise, all latitudes are going to have a compass direction, either north or south on it. All right. Now, so you're measuring north or south of the equator. Now, finding your latitude is actually really easy. And within about a minute here, I could tell you how to find your latitude if you're lost in the woods or something. How you can do that is by locating Polaris. And what Polaris is the North Star. All right. Now, how do you find the North Star? Well, actually, it's incredibly easy to do. All right, so what we have over here, this is the flag of the great state of Alaska. And the reason why I have the flag of the great state of Alaska on here is not because I'm from Alaska or that I've ever even been to Alaska. The reason why I have it up here is because the flag of Alaska shows you precisely how to find the North Star Polaris. All right, so how do you go about doing that? Well, first off, you find the Big Dipper. All right, the Big Dipper is by far the easiest star constellation to find. Big Dipper just looks like a big giant dipper, a big giant ladle. It's really big, the stars in it are really bright. All right, so you find the Big Dipper, which is really easy to do. Then what you do is you take the last 2 stars off the Big Dipper right there, and then you follow those up and you point it to that spot right there. Now in this section of the sky, now the North Star is not the brightest star in the sky. There's lots of other stars that are brighter than Polaris, the North Star. However, Polaris is the brightest star in this section. So if I could find the Big Dipper, then line up these last two stars in the Big Dipper and follow it up like this, I'll be able to find Polaris and North Star. Now the thing is about Polaris, not only does it tell you what direction north is, but also whatever the altitude Polaris is in the sky, that tells me what my latitude is. All right, so if I were to look up in the sky and I see Polaris right there, and I look up and this is a 45-degree angle to Polaris, that means the sky is located at 45 degrees north. If this guy were to look outside and he sees Polaris at, let's say, a 25-degree angle, that means that guy's latitude is 25 degrees north. If I was outside and I looked up and I saw Polaris directly above me, and that was a 90-degree angle, that means I'm at 90 degrees north latitude, which should be at the North Pole. If I'm at the equator, Polaris would be right in the horizon, 0-degree angle. If I live in the southern hemisphere, like Australia, you don't see Polaris. You only see Polaris in the northern hemisphere. Now, in the southern hemisphere, they can do basically the same thing with the stars they see down there, because they see different stars in the southern hemisphere than we see in the northern hemisphere. But they could basically do the same thing with some stars down there. But in this class, because it's New York State, we're usually just concerned about things that affect the northern hemisphere. So whatever the angle Polaris in the sky is, that is your latitude. So it's very simple to find. People have been able to find latitude for a very long time. All right, so that's latitude. That measures how far north and south you are. Longitude measures how far east and west you are. All right, and just like with latitude, our reference point, our starting point was the equator, or is measuring how far north or how far south you are of the equator. With longitude, what they use is something called the prime meridian. So what the prime meridian is a line that starts at the North Pole and it cuts through Greenwich, England, and it goes to the South Pole. So notice the prime meridian only goes halfway around the Earth. It goes from the North Pole through Greenwich, England to the South Pole. All right. Then everything from here to 180 degrees this way is east longitude. So there, going this way 180 degrees is east longitude. Then from there, going this way 180 degrees is west longitude. And kind of the same idea as with your latitude, your longitudes, you have to make sure you put a compass direction on it. I can't just say it was at 75 degrees longitude. I need to say whether it was 75 east or west longitude. All right. So the prime meridian has a longitude of 0. Right. Then from here, now these would all be east longitude. Then from here, these would all be west longitude. Now on the complete opposite side of the prime meridian, it's going to be going like 170, 171, 172. All the values of longitude are going to go up to like 179. Then it's going to go to 180. So if I'm at 180 longitude, there's no compass direction on that either. It's just 180. So 0 degrees longitude, there's no compass direction on. And 180 degrees longitude, there's no compass direction on. But everything from like 1 to 179 would be east, and then 1 to 179 would be west. All right. So that is longitude. Now, the Earth, it takes the Earth 24 hours to rotate once, right? And with the longitude, if there's 180 degrees east and 180 degrees west, That means there's 360 degrees of longitude. So 360 degrees divided by 24 hours, the Earth rotates 15 degrees of longitude per hour. So if the sun was shining there right now, 1 hour later, it'd be 15 degrees farther that way. 1 hour later, 15 degrees farther that way. 1 hour later, 15 degrees farther that way. 1 hour later, 15 degrees farther that way. So the Earth rotates 15 degrees of longitude an hour, and that's roughly where the time zones come from. So roughly on a globe, roughly every 15 degrees of longitude is a different time zone. Now, it's not perfectly 15 degrees because, if it was up to scientists, it would be exactly 15 degrees, but there's political concerns as well. Whereas if a time zone was going to be like 3/4 in one country, if the time zone was going to make it so 3/4 of one country is going to be in one time zone and 1/4 of the country in another, sometimes they might make the time zone go around a country. Or states' borders, they might have the time zone kind of go around states' borders, so you don't have part of the state in one time zone and part of the state in another time zone. But generally speaking, it's about 15 degrees apart for the time zones. Now, finding latitude is extremely easy. You just find the altitude of Polaris, that tells you your latitude. Finding longitude is extremely difficult to do. This was something that perplexed sailors for many, many years. Basically what it boils down, so what would happen is if you don't know exactly how far east and west you are, ships could crash into land in the middle of the night. And it was causing a big problem, and Britain was a big naval power, a big sea power. So to try to solve this problem, they had this big contest where they had this big giant cash prize, and whoever could come up with an accurate way of measuring longitude would win this big giant millions and millions of dollar prize. So all sorts of people were coming up with all sorts of crazy ideas, and they called them longitude lunatics, where these people were trying to come up with these wacky ideas of finding longitude. Basically what it boils down to is you need a really accurate clock. It takes a while to explain, so I'm not going to go into a lot of details here, but what you need is a real accurate clock. And if you know what time it is in Greenwich, England, you know what solar time it is where you're at, you can use that difference in hours between them to figure out how many degrees you are based on the fact that the Earth rotates 15 degrees an hour. So it wasn't until people came up with a really accurate clock could they accurately measure longitude. I mean, nowadays it's easy because you got GPS and satellites and stuff like that. But you go back a couple hundred years ago, it was very difficult. And a lot of the clocks people had back then weren't very accurate. So that's what it boils down to. You need a real accurate clock to do so. All right, so latitude measures how far north and south you are. Longitude measures how far east and west you are. All right, so let's say I have some latitude lines. And maybe this one is 21 degrees, and this one's 20 degrees. All right, and let's say I have another one down here at 19 degrees. Now, first off, on a lot of maps, they don't have the north and south labeled on the latitude or longitude lines. And the reason being is by looking at these lines, you should be able to figure out whether it's north or south latitude. And how I can go about doing that is if I'm looking, if the numbers are counting up, like this is 19, 20, 21, what that means is 0. The equator would have to be down here someplace. So that means all these would have to be north latitude. Or if I had something that was like uh, 70, 71, 72 for the longitudes, since it's going 70, 71, 72, that means it's counting that way. That means 0 would be over here someplace. So these would be all west longitudes because I'm counting it west that way. Okay. All right. But another thing to notice. All right. So let's say I had, that was 20 degrees and that was 21 degrees. And I wanted to describe the location of a point that's right there. All right. Now, one way to express that would be 20.5 degrees. All right. 20.5 degrees would be one way to express that. All right. And with a lot of computers now, that's how they express a latitude, is with just using decimals. So you're starting to see more of that with like GPS and stuff. It's actually not the proper way or the traditional way that latitude and longitudes are done. So if I wanted to describe that point, I probably wouldn't want to just round it to the nearest degree. And the reason being is from 1 degree to the next degree, on average, is about 60 miles. So if there was a city right there and I just rounded it to 21, I'm going to be off my description by about 30 miles. All right, so I want to better describe that location. And again, just using a decimal, again, it's starting to become more accepted, but in a lot of cases, it's not used still. The traditional way of doing it is that degrees are broken up into minutes, just like time is, all right? An hour is broken up into 60 minutes. Well, a degree is broken up into 60 minutes. So there's 60 minutes between 20 and 21. So if something was halfway in between 20 and 21, instead of saying like 20 and a half, just like instead of saying 20 and a half hours, another way I could say it is 20 hours and 30 minutes. Same idea. This would be, if I'm halfway between 20 and 21, that would be 20 degrees. You know, that brings me there. And if there's 60 degrees from there to there, 30 would be halfway between it. So that'd be 20 degrees, 30 minutes, right? So that equals that. Let's say my little X right there was right about there, all right? So if I was describing that, that looks like it's about 3/4 the way up. I might say 20.75 degrees, all right? That's the way that it's gonna appear on a lot of computers. The proper way to write that though is, again, there's 60 degrees from there to there, just like there's 60 degrees on a clock. If it's 3/4 past the hour, that'd be 45 minutes. So same idea here. If it's 60 minutes from there to there, 45 would be like 3/4 the way up. So another way I could write that would be 20 degrees, 45 minutes. So that is the same as that. All right. Now, I said from here to here was about around 60 miles. And there's 60 minutes in a degree. So roughly every minute is roughly about a mile, all right? Which is a lot. So if I describe something to the nearest degree, if I describe something to the nearest minute, I would get it down to within about a mile, which might be okay if I'm describing a location of a city. But if I wanted to describe the location of a street, then I'm going to want something even more precise. So just like time again, each minute is broken down into 60 seconds, right? Each minute is broken down into 60 seconds. So if it was half a minute, it'd be 30 seconds and so forth. Well, if a mile's about 5,000 feet and I broke that down into 60 seconds, that means that each second, if you do the math, works out to be 80 feet apart. So if I describe latitude like this, 42 degrees, 32 minutes, 15 seconds, that would be describing my location to within about 80 feet. So for most things, that would be a good enough description of where you're at. If you have GPS, like on your iPhone, on your mapping thing, you should have a GPS on there. It gives you your latitude and longitude expressed like this. That's what those numbers mean: degrees, minutes, and seconds. All right. All right. Now, in your reference tables, there are a few maps that use latitude and longitude. So you have in your reference tables, your Earth Science reference tables, you have a map of New York on page 3 that has latitude and longitude on it. Then you got 2 world maps, one on page 4 and one on page 5 that show latitude and longitude on it as well. So we're going to go over how to read these maps. All right, so here's the map. It says, this is the one on page, I forget, 3 or 4, whatever. It says surface ocean currents on it. So the arrows represent ocean currents, but we really don't need to worry about ocean currents today. We're just using it as a map of the world. All right. Remember, latitude lines are the ones that you could climb like a ladder. So these numbers on the side are your latitude. Now, I don't know how well you can see it, so I'll make them a little bit darker. Right there is 0 degrees latitude, all right? So this is the equator right there. So this says 20 degrees, this says 40 degrees, this says 60 degrees, this says 80 degrees. 20, 40, 60, 80. So here's the equator right there. These numbers here, even though there's no little letter on there telling you whether it's north or south, I know they're north because there's the equator and the numbers are counting up from the equator. So that's 20 north, 40 north, 60 north, 80 north. And that's 20 south, 40 south, 60 south, 80 south. So those are your latitudes, all right? Now, your longitudes. Now this is where they're kind of nasty to you on the reference table. If the world was run by a beautiful person and everything was rainbows and puppy dogs and lollipops and cotton candy, what they would do for you is they put the prime meridian in the middle of the map and make everything on one side of it east and everything on the other side of west. But the world is not made up of cotton candy and puppy dogs. It is a mean world that what they did to you is they put the prime meridian right there. So there's the prime meridian right over there. Now, why that's mean is because, remember, I'm measuring 180 degrees east or west of there. So there's 0. Here, right here is 180. So 0 going this way, this is west longitude from 0 to 180, all right? Easy enough. Now, for my longitude going this way, that is east longitude. However, it doesn't just stop right there because it goes from 0 to 180. So it's going this way, then it's picking up over here to finish out the 180, all right? So 0 going this way is east, picks up over here. So this is all east as well. So it goes from 0 to 180 west and 0 to 180 east, all right? So if I was going to describe the location of, say like that point right there, all right? How I would describe it is I have a latitude, it's 40 degrees north latitude, and it would be about 100 degrees west longitude. So that point right there would be 40 degrees north, 100 degrees west would be that point right there, all right? let's say I had a point, let's say I had a point that was right there on the map, all right? For that one, I come over there for the longitude, that is 40, or excuse me, the latitude, I'm sorry. I come over here for the latitude, that's 40, and I come over here for the longitude, all right? So this is gonna be 40 degrees north because it's above the equator. And for my longitude, it's gonna be 80 degrees east, right? Because remember, it goes 0 to 180, 0 to 180. So that'd be 80 degrees east. So this location right there, I'd write as 40 degrees north, 80 degrees east. All right. If there was a spot, let's say it was down right about there. All right. My latitude, I come this way for my latitude, so that'd be 40 degrees. There's the equator right there. So that would have a latitude of 40 degrees south. And then my longitude would be like right about there. And that'd be about 60 degrees east. All right, so that right there would be 40 south, and then 60 degrees east. So that's how you define locations on that map. And you have two world maps in your reference tables, and you both find latitude and longitude pretty much the same way on that. All right. The other map that you have in your reference tables is a New York State map that looks like that. All right. Now, looking at this, remember the numbers on the side of the map are the latitudes. The numbers on the side of the map are the latitudes. So that'd be like these numbers right there. So again, I'll darken them in so you can see that better. That's 42. That's 43. That's 44. That's 45. Right? 41's down there. All right, so 42, 43, 44, 45. Now, they're not labeled north or south, but because they're counting up like this, that would mean that the zero, the equator, would be down here someplace. So in New York State, all the latitudes are north. So these would all be north. Again, it's not labeled north because you're expected to know that if it's counting up, it's north, but those are all north. All right, so those are your latitudes. All right, your longitudes. All right, you find your longitudes either on the top or bottom of the map. So those would be these numbers right there. So there's 76, 77, 78, 79, there's 75, and so forth. Now again, these aren't labeled east or west, but you're supposed to be able to figure it out that since the numbers are going 75, 76, 77, 78, 79, that zero would be over here someplace, and it's counting this way from zero. So the numbers are counting west. So again, even though they're not labeled west, all the longitudes in New York State are west longitudes. All right. So let's say I want to describe the location of Watertown, New York. Watertown, New York is right there. All right. So the location of Watertown would be, there's my latitude, and there's my longitude. So the approximate latitude and longitude of Watertown would be 44 degrees north, 76 degrees west. All right. All right. Let's say I wanted to find the, let's say I want to find the latitude and longitude of Ithaca. All right. Now, Ithaca is right about there. All right. So when I come over here, all right, Ithaca is about halfway between 42 and 43. All right. So remember that every degree is broken up into 60 minutes. So if I'm halfway between 42 and 43, how I'd rate that would be 42 degrees, and the number of minutes, again, there's 60 minutes from there to there, so half of that would be 30 minutes. So it'd be 42 degrees, 30 minutes, and again, that would be north. And for my longitude, it's going to come right there, and if you look where that works out to be, it's about halfway between 76 and 77, so it would be like 76 and a half, but the proper way to write that would be 76 degrees, and again, since there's 60 minutes in a degree, half of that would be 30, so it would be 76 degrees, 30 minutes west. So the coordinates for Ithaca would be about 42 degrees, 30 minutes north, 76 degrees, 30 minutes west. All right. So that is how you do the latitude and longitude on the map of New York State. So you're going to be doing an assignment where you're going to be given the maps. You're going to have to use the world maps and the maps in New York State to locate it. So that's how you do that on here. All right. So that is latitude and longitude.